Section 24.6 Driving Forces of Air Motion. So due to multiple effects, the sun's position, cloud cover, all the other effects discussed in the last section, the surface of the earth is heated unevenly. And the uneven heating of the earth's surface is what drives the motion of the air. As air is warmed up, those molecules gain kinetic energy and they collide more often. This causes the air to expand. Expanding air decreases in density and the air rises. As it cools, then, those particles start to slow back down, the air contracts and sinks. The process of warmer air rising and cooler air sinking generates what's known as a convection current. And this convection current effectively stirs the atmosphere and generates wind, or essentially air with an average horizontal motion. Wind is generated in response to differences in pressure caused by differences in temperature and differences in density in the air. That difference in pressure is referred to as a pressure gradient. And the pressure gradient force is what causes air to move. So in terms of the Earth as a whole, the equator sees more sunlight overall than the poles. So the equator in general is warmer and you have higher temperatures there. And those higher temperatures would cause the air to expand and rise until it reached the poles where it cooled and sank. And if the Earth didn't rotate, what you would see is large-scale motion of the air from the poles to the equator. However, that motion of the air does not occur. Rather, the Earth rotates, and because we are on the Earth rotating with it, when we experience winds, we experience them deflected by the Earth's rotation. And this deviation is what's known as the Coriolis effect. The Coriolis effect is just the deviation of the path of straight-line wind due to the rotation of the Earth. Now, the latitude and the wind speed determine the amount of deflection. The greatest deflection is going to occur at the poles, and the least amount of deflection is going to occur at the equator. Slower winds will be deflected less, faster winds will be deflected more. Winds at the surface of the Earth do not experience great amount of deflection because they're slowed down by frictional forces from the air being in contact with the surface.